Okay, it's 5 past, so I think we're comfortable to start now. We got a big room already, so good morning, everyone, and welcome to this webinar that we're hosting for you today. As you could see from the title, New Build versus Refurbishment, the role of carbon assessments in decision making. This session today is all about highlighting the great work that one of our customers, Cudd Bentley, is doing to decarbonize their projects. My name is Bernardo Silva. For the ones that don't know, I work in the account management team here at One Click LCA. Obviously, it's my pleasure to be hosting this session today. So I'll just do a little bit more in-depth introduction about myself. I'm an account management specialist at One Click LCA, and I'm specialized in the UK and Ireland markets. I have a background of sustainable business management. I've joined the company in early 2025, and I have focused on advising accounts how to best use the software for designers, constructors, asset owners to achieve and demonstrate sustainability goals, often including life cycle assessments, LCAs, embodied, and operational carbon reduction. And now over to our Cudd Bentley team.
Hello, everyone. I'm Ahmed from Cudd Bentley Consulting. I'm the senior sustainability consultant. We have been preparing different types of sustainability reports, all types of carbon assessments, energy assessments, BREEAM lead assessments. Colleague Vibhuti will introduce.
Hello, everyone, and welcome to the session. It's great to see so many passionate people around here. So I'm a sustainability consultant at Cudd Bentley Consulting, and I work with a lot of whole life carbon assessments, net zero, and circular economy reports. We also work with BREEAM and lead assessments. And it's great to see you all and looking forward to the session now. Cheers.
Very good. Thank you, Ahmed and Vibhuti. Okay, I will now kick us off basically and just give you a little bit of introduction before we get into the case study presentation of who we are as One Click LCA. For those of you who aren't familiar with One Click LCA, right now we are the market leading sustainability platform for decarbonizing projects and products across the built environment, with the mission to power the makers of a zero carbon future. We often work with our customers towards their sustainability goals, be it 2028, 2035, and help them make those ambitions real. You can see the numbers from the screen growing month by month, and I will also share a little bit with you now on who we work, from architects to consultancies to big infrastructure companies, sustainability practices. Of course, a little bit of feedback. You can see probably some names you recognize. And without further ado, I will pass to Ahmed to start the case study.
Thank you, Bernardo. So today we will talk about the role of carbon assessment in data-driven decision making. And in this webinar, we will talk about the role of carbon assessment in evaluating refurbishment versus new build scenarios, and what are the benefits of this assessment for low carbon design decision makings. We will also present one example, and we will compare both scenarios. And we will talk about building services, carbon modeling, and also the carbon data meaningful to the client's design teams. And as we prepare all types of sustainability assessments for like double greenhouse gas and BREEAM credits, LEED credits, One Click helps us to prepare this. The first step is we need to prepare the One Click model for that one. And for the other projects, we use different tools, but we will appreciate One Click for their detailed database, which help us to prepare the model and do the assessment accurately. So I'll give a quick introduction about the WLC. WLC is a numerical assessment method to assess the environmental impact associated with a building over its entire lifespan. And in this WLC, we actually include all the phases of the building, from construction stage, which is module A1 to 5, then in use stage, which is module B1 to 7, and end of life stage. That's a very important thing for WLC, because there are some other assessments where I mean the scopes are very limited, but for this WLC it includes everything, and that's why it's very important for from the early stage design to decide which option is the low carbon options. And for these assessments, we analyze the design first. We collect the bill of materials, and then all the electrical mechanical information, energy consumptions, and then we start preparing the one-click model. The aim of this assessment is to get the optimum solution, because in our assessment we try to assess few scenarios, few option appraisals, and then try to find it out which one is the actual low carbon options, because you can't see that. You need to do this math, you need to do the model, then you can find it out. The data will tell you which one is the best option, and from that assessment you can find it out the best solution, and how we can reduce that emission with some active and passive measures, and how we can make it more efficient. This is the RIGS lifecycle modules. I'm just showing it because there are some people who doesn't know about these categories. You can get this from in the RIGS guidance. I recommend to read it because we also follow these RIGS categories, also read RIGS scopes for building elements. And in this WLC assessment, actually, we can get the holistic design decision, which is more sustainable. I mean, if we just place green roof, green wall, it doesn't mean it will be sustainable. We need to assess all the building materials. We need to prepare the model accurately. Then we need to do the assessments, including materials, building service systems. Then we can find it out the optimum solution. And in this way, where before taking the design decision, when we have an existing building, sometimes we can see some people thinks like demolish everything first, then we'll think about it. But we will say no, before demolishing this one, you should think about how you can reuse that building, recycle that materials, and in that way you can reduce the carbon emission, you can save your cost. There are so many benefits for that one. And in these assessments, we can also find it out where are we standing against the benchmark, because at this moment there are many benchmark. We'll show them in the next slides. And also we can find it out for the reduction strategies. And considering the global context is also very important, because we all are aware of the UK net zero target. To achieve that one is very important. Also, in many countries, internet, they have some specific targets, specific guidance. So all of them are trying to reduce the carbon emission, and to reduce that one, this holistic approach is very important. Also for the investors, as part of their ESG policy, it's kind of a requirement now. And also for the PARZ, new PARZ requirements, it's also important. So this is the projection of carbon reductions. To achieve that one, we need this proper assessment. And the timeline of the assessment, I will say the ideal time is when the design is ongoing, because sometimes we can see some people, in some cases, they are completing the design, then coming to us to find it out. What's the emission? We'll say it's already too late. When the design is already done, the door is closed. Okay, fine, you're achieving the target or you're not achieving the target. The right time, when the design is ongoing, before taking the decision of demolishing anything, you should do the sustainability assessment. Then you can find it out the right solution. And after the stage 3, and in between stage 3 and 4, you should check the carbon figures again, because at the time there are many changes in the design, material selections, and after stage 6, finally you can get the actual result, what happened in your as built. Then for this embodied carbon assessment, we also try to follow the UK Green Building Council framework, because decarbonization is very important. And for these decarbonization phases, operation and embodied both are important, I will say. And that's why we try to follow this UKGBC framework. And net zero claims and potential green, I will say, before doing the proper assessment, it's hard to say which one is a low carbon solution. I mean, by viewing some drawings, you can't predict like what will be the carbon figures. So to avoid any kind of greenwashings, it's better to do the assessment, better to prepare the model, do the math, then you can find it out. And after applying the reduction strategies, we also talk with the carbon offsetting strategies that helps to reduce, make further reduction. And now I will invite my colleague Vibhuti to talk about the standard method process.
As Ahmed already introduced about WLCA and what is it about and what is its role in the current situations, considering the policies and everything, I'm just gonna run through the assessment methodology. So everybody knows that WLCA assessments are becoming central to net zero strategies. And about 50% of buildings' lifetime emissions are embodied to material and construction. Before we start conducting the WLC assessments, we obviously need to identify the relevant policies. If the site is located in London or nearby, the GLA policies applies, and then the UK GBC, LETI, and some other benchmarks that can be followed and some other policies. To start off, we start with collecting the data, the bills of materials or the BIM models, and then input it following the RICS methodology to calculate the embodied materials. Then, of course, it also includes inputs from energy consumption and mechanical specification. And for that, we need to liaise with the energy modeling team and then the mechanical team. Later on, we follow the normal method of inputting all the data into One Click, which has been a really helpful tool for us. And then, of course, analyzing the results and reporting it. So to do that, we obviously have different methods. We compare it against the baseline option, which is another model we create, which is based on the industrial standards, and then what are the chosen strategies. And then, of course, to recommend further reductions, we also identify some other option appraisals. Definitely, we follow the RICS categories. Obviously, the key categories are substructure, superstructure, finishes, FFE, services, external works, prefab, if there is any, and then if there is any refurbishment or retaining of structures, we obviously work with the existing building as well. And then if there are any other preliminary strategy or any structures that are being installed. And then to get some assumptions on energy and mechanical specifications, as already mentioned, we have to contact the mechanical teams for confirmation on what sort of services they're going to be using, and then implementing any air source heat pumps or any electrical boilers or gas boilers and stuff like that. We need to confirm that and then follow the TM65 guidance to see what kind of refrigerant is being used. And then for the energy calculations, we follow the TM54 guidance, the operational energy reports, which is again based on the energy modeling. And then this is sort of an overview of how we input everything based on the RICS elements, input everything on the One Click model. So this is sort of how it would look. And obviously, once we add an element or some material, we check what would be the lifespan. We check if there is going to be any recycled content in any of the materials. And then from there on, we update that based on either the RICS guidance or confirmation from the clients or the contractors. And then I'm just going to touch base about some of the standard benchmarks. As you all already know, there is obviously the standards that we follow is the RICS Whole Life Carbon Assessment for Built Environment, the BSEN 15978. You can also follow BSEN 17472 Part Z and the London Plan guidance. And the benchmarks we tend to follow are LETI benchmarks, the REBA build targets. The REBA build targets are usually followed at the post-construction stages, and then the WLC, GLA benchmarks, and then now we have the UK net zero carbon building standards benchmarks as well, which are fairly new, but the guidance is really helpful, and it helps us to identify where we stand in the current date and time. And then I'm going to pass on to Ahmed to talk a little bit about the LETI and the UK net zero standards.
Before this UK net zero carbon building standard, we were using LATI and London Plan GLA guidance, GLA benchmarks, RIBA benchmarks. The thing I will mention in LETI guidance, you can see that we had only like 5 categories, but when we were doing some different categories like data center, it was confusing which category to follow. In that point, I will appreciate UK net zero carbon building standard. They have different categories. You can see this is the benchmark table where they have the categories for all types of buildings, so it's more specific. This is the energy targets, and they have the targets for each year. And this is the embodied carbon target table. They also have these targets for all categories and each years, which is helpful to be more specific and compare the results. Now, one case study, I will talk about this one. This is one industrial building, and there was existing building as well. So in these cases, we have seen many times the team is demolishing it before doing any assessments or any design decisions. But I will say, if you do the assessment properly first, then you can see it's potential to keep the existing building in many ways. Not all the time, as I said. It depends on many scenarios how we can reuse or recycle, because each cases are different. Now, in these cases, when we had this existing building, we had 2 scenarios. Scenario 1, in the left side, keep the existing building and do the extension and do the refurbishment of the existing building. Scenario 2, demolishing everything and prepare the new build. In some cases, people prefers for the whole new building, because they can say it's quicker or to get the materials. In many cases, it's easier for them. But I'll say it's very old thoughts at this moment, because there are so many construction strategies where we can quickly refurb the existing building, and when we are reusing the existing structure, it also saves your time, your money. So then we thought that we will be analyzing this both scenario for one project, and we followed the same process that my colleague Vibhuti already explained. We prepared 2 design decisions, materials, and then collected building service related informations, energy consumptions for both scenarios. Then we prepared the one-click model, and finally we got the results. So in the right side, you can see scenario 1 was 417 kg CO2 per meter square, and scenario 2 was 511 kg CO2 per meter square. So almost we can see 100 kg CO2 per meter square difference in both scenarios. In the left side, you can see this is the most contributing materials. So usually the substructure, like or the concrete, steel, cladding panels, their PV panels in some cases are the most contributing materials where we need to focus. So if we are reusing the substructure and structure, you can save a huge amount of concrete and steel, and potentially you can save at least in between 100 to 200 kg CO2 per meter square. Is for one specific project, I can say it was like 800,000 kg CO2 in total, so almost 800 tons. So which is significant, I will say. And then we compared this with the benchmark. So overall, when we were looking back to these options, and as we did these assessments during the design process, this helped the design team take the decision. And finally, as we can see, their advantages of carbon reductions, cost, time. Finally, the scenario 1 was the final decision to keep the existing building, do the refurbishment, and do the extension. And after that, we think about the materials, because refurbishment or new build, this is the major decision where you can significantly save the carbon emission. And then still you have the option to select the low carbon materials, which helps the reductions. And for this one, again, in the one-click model, when you include all this information, and in the result section, you can see the carbon emission for each material, for each categories. So you can focus where you can see that the carbon emission is very high for that specific material or for the specific part of the building. You can rethink about that one. You can find it or some other options. You can talk with the design team. You can serve in the market. So this is how it helps us to identify the main points where we can do some options and reduce the carbon emission. And also this is kind of one example where we prepare like the baseline versus the baseline material selections. Then we also place some recommendations, set of 1, 2, or 3. It depends on the projects. um, and then we try to find it out which option is the best option. So we prepare multiple one-click file and then compare the results. And also when we are reusing the existing structure or building, it also helps us to achieve the circular economy principles, where where it's saying to reuse and recycle as much as possible. So we can also achieve like longevity, adaptability, flexibility, reusability, recoverability of the building materials. And there are many short-term and long-term advantages when we can achieve this circular economy principle, for which we need to make sure that we are reusing and recycling as much as building material as possible. And also we can achieve the key commitments easily when we are refurbishing the building instead of demolishing it. As for the London Plan guidance, we have the targets for 95% diversion for from the landfill for construction waste, also the excavation waste, demolition waste. We can easily achieve all these key commitments and targets. And also for net zero targets, it helps us to achieve all the net zero targets, because when you are reducing the carbon emission, refurbishing and you reusing the building, in that case your overall carbon emission for the whole life stages will be lower, which helps you to achieve the net zero carbon. And still, if the amount of carbon you need to offset with your carbon offsetting strategy, that amount will be lower, so your carbon offset cost will be also lower for these phases. For this net zero building, again, we use this UKGBC framework, then the LATI targets, then UK net zero building standards, and also we follow the same one-click process and analyze the building materials. Also, we prepared this option appraisal. From that one, we can find it out which option is helping us to achieve this net zero carbon for this development. Sometimes we have seen, to decarbonize a building, some people are thinking that we are just offsetting the operational carbon. In that case, when they are including huge amount of PV or like huge thickness of insulations, building materials to achieve better U value, that maybe that is helping to reduce your operational carbon, but at the same time it's increase your embodied carbon. So we need a balance in between the operational and embodied carbon emission to get the actual net zero building. So if you're just reducing the operational, you're not touching the embodied, you're not thinking about it, then it's only net zero in operation, we'll say. It's not truly net zero. So to achieve the UK targets, even the international targets, which is true net zero carbon targets, you need to have a balance of reducing the specific amount of operational carbon and also the specific amount of embodied carbon. So that's why we work with both assessments simultaneously. We think about the operational emission, we think about the material emissions. Like some materials, we have seen some especially some claddings, which are which are good when we are thinking about the thermal properties, but that's not sufficient. But when we are checking the carbon emission, what's happening, what are the materials, what are the ingredients they are using, then we can find it out that this is not the right material, we shouldn't go with that one. So it's not something that we can just check some of the items and skip some of the items. We need overall assessment to find it out the right materials and right low carbon solution for that building. This is for this part also one click help us, because when we select some materials considering the thermal properties, then when we prepare the one click model, we can see the actual emissions for that materials and also check the EPD. Also one click has a good library for the EPD So in the EPDs, we can check and find it out what's happening, what's the ingredients of that material. Shall we go for it? Because at this moment, there are like, if you search for concrete, there are like hundreds of options. So trying to find it the actual option is very important. And like all of them are not, I mean, not necessarily if you're spending a lot of money, that doesn't mean you'll get the low carbon material. So it's a matter of doing the assessment properly, right time. And finally, with our refurbishments proposal, and when as we did in the right time, and we thought about, we in our assessment process, we did some actual calculations, and where is still, as the many options were not present at the time, we did some extra work, and we also talked with the team as soon as possible before completing the design, and we did couple of options, and finally we got the right options. And for that our extra effort, we received the finalist award in 2025 in new Unlock Net Zero Award, and 2024 as well. That was for a different assessment. So that's it for today. I will pass this to Bernardo.
Thank you very much, Ahmed and Vibhuti. I think this was very good to understand how Cudd Bentley integrates carbon modeling into the building services engineering, and also to reflect on whether you're navigating a complex retrofit or debating demolition and rebuild. This helps understand how carbon modeling informs smarter, more sustainable choices. So good job, Ahmed. So I got this question. What is your roadmap for incorporating more detailed MEP, so mechanical, electrical, plumbing systems, into the assessments? The answer is One Click LCA has a dedicated MEP carbon tool already, specifically for this purpose. It's designed for MEP engineers to conduct detailed assessments, and addresses the fact that MEP can account for up to 50% already in its methodology of a commercial building's embodied carbon. A little bit of the technicalities of it. It uses SIP's TM65 data for calculations. We have access ready-made for MEP assembly, so electrification per square meter for an office. You can choose from our global database of manufacturer-specific EPDs for MEP products, and generally it accounts for refrigerants, operating energy, water, and end-of-life impacts. Then second one, I have on data and methodology. Questions coming, okay. Thanks for the presentation, both. I observed that the model BC for the refurb scenario was lower than new construction. What was the main reason behind this?
Right. The thing is, we collect this B6, regulated and unregulated, both from our energy team, where they prepare the energy model and simulations, then find it out the results for both scenarios. Said model B6 scenario 1 is lower than scenario 2. Right. We decided to use the same service systems. Definitely there are some difference, for which I can see there is a difference of B6 module. As I said, we prepare many options with building service systems as well, many types of heat pumps. So there, it should be something difference with the services. But our main decision was based on module A1 to 5, which is the construction stages, which is the building materials. So this is where we, the amount I saved, like around 100 kg CO2 was saved, is based on the module A1 to 5.
We have got as well a question from Jennifer. Welcome, Jennifer. Thanks for presenting, for very interesting presentation. Your options case study, it can be very challenging to obtain accurate material quantities for design options at early design stage. How did you achieve this?
I agree. It's a big challenge to get this right information. Even in some cases, most of the cases, I'll say, we struggle to get that information. So we try to interact with the design team as much as possible. Maybe even sometimes they don't want to issue all the material details, but as I say, this very early stage, then we try to arrange some more meetings with them, try to understand what are the thinking, wherever they are thinking about the materials, or from their previous experience, what are the thinking to propose it after getting the planning permissions. So this is how we try to cover the gap, by talking multiple times in multiple meetings with them to understand what are the thinking about the materials, service systems, with the architects, structural engineers, MEP engineers, and this is how we collected the information.
So I'm going to proceed with one of the other questions we had received prior. The question was, when comparing materials in the materials compass, one of our tools, how does the tool account for differences in performance and service life? The answer is that the materials compass is primarily a tool for comparing the environmental impact of materials based on their EPD data for declared units. An example will be 1 kg of steel or 1 cubic meter of concrete. The consideration of performance and service life happens within the building level LCA tool. So when you use a material in your building model, you define its service life. If a material's service life is less than the building's 60-year study period, the usual normal within the UK, the tool automatically calculates the impacts of its replacement module before, ensuring more or less a fair performance-based comparison. How do you ensure that using only an embodied carbon metric doesn't lead to unintended consequences?
As I said, it's not only embodied carbon metric. We prepare all other sustainability assessment for these developments, but in this one, we also include like the energy consumptions, P6 regulated, unregulated, then the occupancy based on so water consumption based on the occupancy, then also building service related information. So it helps to give you an overall picture of the construction in use. Also, we in our module B1, 2, 3, 4, where we have the carbon emission for repairing refurbishments, we also consider them. Also, after end of life, what will happen? So we are also including that one. So it's giving you an overall picture. So this is helpful, I will say. It's not the only assessments, then definitely the cost related information, project timelines. So considering all the metrics, then we decide, but it's not the only one, but it helps you to give you the overall carbon emission picture.
I've got on my side one last question. I'll just answer one of the questions that came in. The question was, with regulations constantly evolving, what is your process for updating the platform to align with the new standards like the UK Net Zero Carbon Building Standard? The answer is One Click LCA consistently updates its tools to align with new and evolving standards. Our track record has been pretty good, showing that we quickly adapt to major new requirements. For example, the latest one, we were the first software to be officially validated by RICS for the new RICS V2 standard. Michael asks, what are your views of the use of Module D to accurately assess circular economy impacts?
Actually, for Module D1, we can get some information from One Click, but it's hard to assume at the early stages of the projects. So when we are comparing this one, we try to focus on module A1 to 5, because that's the construction stage at this beginning of the projects. We can estimate like it's a major stage where we can save a significant amount. So module D is kind of an estimation. We just did some high-level estimation for the module D. Also some estimations for module B, because that's the next stages.
So thank you, Ahmed. Thank you, Vibhuti, for your participation. I'm sure we'll continue having examples of the good work you're doing, and we'll keep monitoring everything and trying to help in the best way possible.
Thank you very much.
Thank you.
Thank you.
Got our comments. Thank you. Thank you, everyone. So I think we'll wrap up and end the event. Thank you, everyone. Lot of good interactions. Thank you.